Hi, Transitional Math students. Mrs. Robinson here to work Practice Benchmark Chapter 6 with you. This whole chapter is on percents and percent equations. Percents are super useful. You use them when you go out to dinner and you have to give a 20% tip, or you need to figure out 15% off of something. So this is a great chapter. Let's look at the first one. This one asks for it says 75% is 125% of what number? Now, I prefer percent equations here, but the first chapter talks about setting up a proportion with your ratios. So a proportion would look like this with percents. You would have a part of something to a whole of something. Now remember, percent means per 100. So your part with the percent would actually be the percentage out of the whole, which is 100. Okay, so this would be the percentage out of 100. So your part to your whole and the percentage out of 100. Now this one's kind of weird because it asks for 125%, which is actually more than 100. It's bigger than the whole. That's okay. Just set it up just like this. Your part to your whole. 75% is 125% of what number? We'll do your percent here. Your percent is 125. It's bigger than the whole out of 100. And 75 is 125% of what number? So 75 here is going to be our part, and we want to know what is the whole here. Okay, so what's the whole? So 75 is 125% of what number? So it's not really a part because it's actually bigger than the whole in this scenario, but 75 is the 125%. And then we have to figure out what this denominator is. So we go 75 out of x is 125 out of 100. We're going to cross multiply, and we're going to go 75 times 100, which would be 7,500, equals 125 times x. That's a 2. Sorry. This times this and this times this. Now to solve for x, this is multiplied. So to solve, I divide by 125 on both sides. And you're going to come up with x is equal to, and if I just go ahead and do 7,500 divided by 125 on a calculator, I'm going to get 60. Okay. See if that's a reasonable amount. Is 75 125% of 60? Yeah, because 75 is bigger than 60, and 125 is bigger than 100. So if I take 100% of 60, I get 60, and then 25 more percent is going to give me 75. All right, so that seems reasonable to me. Now, if I were to do this as a percent equation, this is how I like to do it. I write my percent equation just based on what I read. I write it just like this. 75 is, that means equals, 125%, 125%. Of what number? Whenever they say what number, I just put an X. Okay, 75 is 125% of means multiply times X. Now to change to a multiply, I got to change that to a decimal. So I just write it like this: 75 equals 0.1. Oh, excuse me, I was just kidding. To change from a percent to a decimal, you move over 2 spots. 1.25 times X. Now solve for X. Divide both sides by 1.25. Simple as that. And if I do 75 divided by 1.25, I'm going to get 60, and that equals x. And there you have it, same answer. So that's why I like the percent equation. It's more straightforward. Okay, number 2, which proportion can be used to find what number is 44% of 50? Remember, if you go part to whole equals percent out of 100. If I were to set this up, which proportion? Well, which proportion can be used to find what number is 44% of 50? So if I have 44%, that's going to be 44 out of 100. And I want to know what number is 44%. So that's my part, and my whole is 50. So my part to my whole equals my percent out of 100. And this is how I'd set this up. So the answer would be A. And then I could cross multiply and solve. All right, on to 3. Of the 125 country songs on Howard's MP3 player, 14 are recorded by a female. 14 is what percent of 125? So if I wrote this as a percent equation, I would say 14 is what percent, so I'm going to put an X and this will be a percent, of means multiply, 125. Now I just solve for X. The opposite of multiply is divide, so I divide both sides by 125. That cancels, and I'm left with X equals 14 divided by 125. So I'm going to go 14 and divide it by 125, and I'm going to get 0.112. Now this is as a percent, so to change from a decimal to a percent, I move over 2 places. So this would be 11.2%. And there it is, C, 11.2%. Real quick, if you like to use the proportions, if that's how you've learned this, if you want to set this one up as a proportion, 14 is what percent of 125? Well, you would say there's 14 out of 125. That's equal to what percent out of 100? And if you notice, 14 out of 25 is what I end up doing anyways. You would cross multiply, and then you would already be in the correct percent. You would go 14 times 100, which would give you 1400. And that equals 125 times X, which is 125X. Then divide by 125 on both sides. And you would come up with X equals, this would just give you 11.2% already. You wouldn't have to move the decimal over because you already multiplied by 100. Multiplying by 100 is how we move our decimal over 2 places. So you get the same solution if you set up the proportions, if you prefer that way. Okay, results from a survey show that 36% of dog owners say their dogs sleep in a family member's bed. If 12,500 dog owners were polled, how many of them made this claim? So we just need to know what 36% of 12,500 is. When you do of, that means multiply. I'm going to go 12,500 and I'm going to take 36% of it. Change the percent to a decimal for multiplying. So this will be times 0.36. Remember, move over 2 places. And if I do that, if I go 12,500 times 0.36, I'm going to get 4,500. 4,500. Say that dogs sleep in a family member's bed. Okay, number 5, 36 of 80 marbles are blue. What percent of marbles are blue? So the part is 36, the whole is 80. We're just going to go part to whole. Now, if you want to just do this division, you can, and then move the decimal over 2 places. Or you can go part to whole is what percent out of 100, and you would cross multiply. 36 times 100 would be 3,600. That equals 80 times X, which would be 80X. Divide by 80, divide by 80. So you end up dividing by 80 anyways. If I got 3,600 and I divide by 80, I get 45 equals X. So 45%. Now, if I didn't want to set up the proportion, I could just go part out of whole. If I go 36 and divide it by 80 on a calculator, I'm going to get 0.45. That's not my percent because I didn't do percent out of 100. All I do is move the decimal over 2 places, 45%. All right, of 80 fathers surveyed, 33 of them said they'd like their lawns mowed for Father's Day. What percent is 33 of 80? So all I have to do, once again, I can set up a percent equation, or I can say 33 out of 80 equals X out of 100 and cross multiply, or I can just do 33 out of 80, do the division. 33 divided by 80 is going to give us 0.4125, and then to change it to a percent, I move over 2 places and I land right there. Oops, that wasn't very good. 1, 2, I land right there. So it's 41.25%, and that would be C. All right, which is the best estimate for a 0.5% of 385? Well, let's think about 10%. If I want 10%, if I move that to a decimal, it's 0.1. So basically I move over 1 decimal place, okay? So 38.5 would be 10%. 1%, if you change that to a decimal, it's 0.01, which means I would move the decimal over 2 decimal places. So 1, 2, and land right there. So it would be 3.85 would be 1%. 38.5 would be 10%. So 3.85 is 1% of 385. If I want half of that, so think of this, 385, that's about 4. Half of a percent would be half of the 1%. This is 1%, I want half of it. So if I have about 4, half of it is about 2. And think of it logically, if I want half a percent, not even a whole percent, half a percent of 385, well, it's going to be a pretty small number. And if you look at these choices, 2 is the only really small number. So think of it logically, all right? Since it's multiple choice, use your reasoning skills. This is a great skill, guys. The best estimate, if you want a 15% tip on a restaurant bill, and here's your bill, $88.90. So here's how I might do this in my head if I'm sitting at a restaurant. $88.90, that's almost 90 bucks. So I might go like this. Okay, that's 90 bucks. I'm going to move the decimal over one place for a 10%, okay? So that would be $9. $9 is your 10% tip, but you want 15%. So if $9 is 10%, another 5% is half of that, which is 4.5. Half of 9 is 4.5. So 10% is $9. 5% is $4.50. Add those together, you're going to get 9, 10, 11, 12, 13.5. So $13.50 would be about a 15% tip, an average. So once again, round this to about 90, find 10% of it, that's 9 bucks. Well, you really want 15%, so find half more of that. Take your 9 bucks and divide it in half, and you get 4.5. So there's your extra 5%. So 10 and 5% together is your 15%. And that's how I would do that in my head. A lot of times with 20%, I would just go, oh, well, round it up, 90 bucks. 10% would be $9, double it for a 20% tip, $18. That's how you do it. Okay, so this one, 28.5 is what percent of 20? I might write this as a percent equation. I would do 28.5 is, so here's your number, is means equals, this is your is. What percent of 20? Well, what percent of 20? X is my what, since I don't know what. Of means multiply. What percent of 20? Now remember, that's a percent, and I'm going to get it in a decimal, so I'm going to have to change it to a percent. So I'm going to go 28.5 is what percent of 20? And divide by 20 on both sides to figure out what that is. X times 20, the opposite of multiply is divide, divide both sides. So I'm just going to do this on a calculator. 28.5 divided by 20 is 1.425. That's equal to X. That is not in a percent. To change to a percent, I move over 2 decimal places. 1, 2, okay? So 142.5% is X. So think about it logically, is 28.5 142.5% of 20? Well, yes, because 28.5 is bigger than 20. So it's going to be more than 100%. 20 is 100% of 20. 28.5 is more than 100%. So if you're looking at one of these and making a guess, you would have to guess this one. It's the only one that's more than 100%. And that's what we get. Remember, if I just do it like this, the percent equation, this gives me a decimal. Move the decimal over 2 places. Unless you want to set up your ratio, you would go 28.5 over 20 is what percent out of 100. That's how you would set up your percent proportion, and then you wouldn't have to move the decimal because you would have that 100 there. Okay, this one, which equation can you use to find what percent 18 is of 125? If I just write this out like it is, it's a little confusing. We're really trying to find 18 is what percent of 125? So this is what I get. What percent of 125 is this? So you can use, the book uses P for percent. I would use X, but it doesn't matter. 18 is what percent times 125. You would change that to a decimal to do your multiplication. But basically, it would look like this. 18 is 125 times P. Okay? So 18 is 125 times your percent. There you go. All right, 80% of a number is 57 and 3/5. What is 15% of the number? So first, let's figure out this part. 80% of a number, well, we got to figure out what that number is. Then we'll do this part, okay? So 80% of a number, I'm going to change 80% to a decimal so I can do an equation. So 80% is a decimal, move it over 2 places, 0.80. I would go 0.80 of a number. Of means multiply, and a number, you can use X or P, whatever you want. X for our number is, so 80%, that's a 0.80, of, that's times, a number, X, is equals 57 and 3/5. 57 and 3/5. Okay, now figure out what X is. Divide both sides by 0.80. Divide both sides by 0.80. This is a multiply, so the opposite of multiply is divide. Cross that out, and I'm going to get X is, I'm going to go this on a calculator, but 3/5 on a calculator, what is that in decimal form? I'm going to go 3 divided by 5 on my calculator, and that's 0.6. So this is 57.6 on my calculator divided by 0.80. So let's do that. 57.6 divided by 0.80 or 0.8 is 72. So 80% of 72 is 57 and 3/5. That seems about right to me. Okay. Now that's not our solution. I figured out what that number is. Now we need to figure out what is 15% of that number. So I'm going to take 72. And I'm going to say, what's 15% of 72? Well, I take 72 and I multiply it by 15%. Move the decimal over 2 places for the multiply. So multiply by 0.15. 72 times 0.15 is 10.8. So make sure you do both parts of the problem, and the answer should be B. All right, a coin dealer buys a coin for $850 and sells it for $1,190. That's a pretty good deal. Find the percent of change. So obviously it's an increase because it starts here and it goes here. But remember, to find the percent of change, you do a little formula. You do the difference between the two numbers divided by the original. Okay, not necessarily which one's bigger, which one's the original. The smaller one's the original here. And if you want to do the actual percent, you would equals X over 100. Or you could just divide this and then move the decimal over 2 places, either way. So the difference, we're going to subtract these two. We're going to go 1190 minus 850. You find the absolute value of the difference, so meaning the positive value. So if I subtract those two, I'm going to get 340. Okay, so there's my difference. And then my original number was 850. So I'm going to go my difference, 340, divided by 850. Now I'm going to do the method where I just divide these and I move the decimal over. If you want to equal it X over 100, you would cross multiply these. They give you the same answer. So I'm going to go 340 divided by 850, and that's going to give me 0.4. Now that is in decimal form. To get it into percent, I move it over 2 places, so that would be 40%. So from here to here, that's a 40% increase. I'm increasing by 40%. And that would be here. Now, if you wanted to set up the proportion, you would go the difference, which was 340 over the total, the original 850 would be your percent proportion, X over 100. And this over 100 is what moves your decimal over 2 places. So if I multiply this, I would get 340 and then 2 more zeros because I multiplied by 100. And then 850 times X would be 850X. Then divide both sides by 850. That eliminates, and you get 3,400 divided by 850, which would give you the 40%. Okay, 40% is the percent of increase. So if I take 850 and I multiply it by 40%, and then I add it to 850, I'm going to get 1190. All right, number 13. In 2 years, the value of a car changed from 14,000 to 11,200. What's the percent of change? Well, look, it goes from 14,000 to 11,000. Cars do decrease in value. This is a percent decrease. You still find the difference. You still do the difference divided by the original to find the percent decrease, okay, or the percent of change. So I'm going to go the difference. I'm going to subtract these two. I'm going to go 1,400 minus 1,100 or 11,200. And I said 1,400. I'm sorry, I meant 14,000 minus 11,200. divided by the original, which actually was 14,000. Okay. If I subtract these two, I'm going to get 2,800 divided by 14,000. Now I'm going to just go ahead and do the division, and then I'll have to move the decimal over 2 places because it's going to give me the decimal, not the percent. 2,800 divided by 14,000 is going to give me 0.2, or 0.2. Move the decimal over 2 places to get your percent, 20%. So that's a 20% decrease from 14,000 to 11,200. And that would be here, -20 for the decrease. Okay, during peak season, a hotel room costs $135 a night. During the off season, it's $90 per night. That's cheaper. And which describes the percent of change from peak season to off season. So if we're going from peak season to off season, it looks like it's decreasing. This is going to be a percent decrease. Once again, I do the difference divided by the original. And then I'm going to go ahead and do that. And then I'm going to get my decimal and move it over to get my percent instead of multiplying by 100. So let's go. 135 minus 90 over my original, which was 135. So you can see it's going down. It's a decrease. If I do 135 minus 90, I get 45. Divide that by 135. Sorry for the messy writing. 45 divided by 135 is 0.33 repeating. Okay, I'm going to do 3 threes here. If I move this to a percent, I move it over 2 places, and this is repeating. This is 33.3 repeating percent. Okay, 0.3 repeating is actually 1/3. Do 1 divided by 3 in a calculator, you'll see it's 0.3 repeating. So this would be 33 1/3%. If you come over and you're like, which one is it? Well, it does decrease, so I know it's a decrease. It's not that one or this one because those are increases. So it's either this one or this one because it decreases. 33 1/3 is the same as 33.3, not 50. So it's A. Okay, Evan buys a suit marked $64.99. He receives a 20% discount. So this is pretty common. You go to the store, think of Kohl's, you go in there and you're just like 30% off or 15% off. What is that? What equation can be used to determine the sale price of the suit? Well, you could do this 2 ways. You could go $64.99 and multiply it by, move this to a decimal, 0.20, and get your amount. And let's just do that just so you can see. That's not going to be one of the solutions though. If you pick A, you would have this wrong because that's not the sale price. That's the discounted price, $64.99 times 0.20. That's your discount price. So you get discounted by $12.99, $13 about, okay? Well, then you're going to have to go 64.99 minus 12.99 to get the actual price that you're going to pay. 64.99 minus 12.99, you're going to pay 52 bucks. So this wasn't one of the choices. 64.99 times this, and then getting your original 64.99 and minusing 12, that wasn't one of the choices. So instead, we go, all right, if you get 20% off, you're actually paying 80%. You pay 100%, this is 100%. If 20% is off, you're paying 80%. So instead, you just go $64.99 and multiply it by 80%. Move it to a decimal, 0.80. And that would be the cost of the suit. If you do that, see if it gives you the same price as this did. If I go $64.99 times 0.80, I'm going to get $51.99. So 51.99 or approximately $52. So yes, it's the same. This is much easier. If you get 20% off, you're actually paying 80%. All right, so that would be, the suit is $64.99 times 80%. Don't get thrown off by this one. That is not the sale price of the suit. That's how much you get marked off. Don't get thrown off by that. All right. And then these would be if you had percent increases. Mona invested $2,840 in a savings account for 6 years at 5.25% simple interest. How much interest did she earn? If we use our simple interest formula, not compound, interest equals principal times rate times time. So our interest that I will earn, that she will earn, I wish I would earn, is the principal, which would be $28.40. Principal is your amount you invest. Your rate, right here, it needs to be in a decimal form. So 5.25 in a decimal, I move it over 2 places, would be times 0.0525. Moved over 2 decimal places and you put a 0 there. And then your time is 6 years. Just do this on a calculator. Your interest should be $28.40 times 0.0525 times 6. And you're going to get $894.06 would be 60 cents. So let's see, $894.60. It should be D. All right, 17, Juliana plans to borrow $3,180. She's borrowing this money at 6.5% interest for 3.5 years. So she has to pay this back. What amount of simple interest should she expect to pay? So this isn't compounded, just simple interest. She's just borrowing this money for this amount of time. How much should she have to pay back in interest? So her interest is going to be her principal times her rate times her time. Okay, so it's better to stick money in the bank and get interest. If you borrow money, you have to pay interest, which is how credit cards work and mortgages and all those things, but they're compounded, unfortunately. All right, $3,180 is the amount you borrow. Your rate, 6.5%. Move the decimal over 2 places. It's going to be 0.065. That will be your rate, 0.065. Make sure it is in decimal form, not percent form. And the time is 3.5 years, and that will be your interest. Go ahead and do the math on that. We're going to go 3180 times 0.065 times 3.5 on a calculator, and you come up with your interest is $723.45. So $723.45. That's how much she has to pay just in interest to borrow that money for 3.5 years. So she's going to pay more than that just to borrow the money. Okay, number 18, what's the total amount in an account after 3 years if the interest is compounded every year, annually, on an amount $3,200 at 4.8%? So there are compound interest formulas, but let's just manually figure this out, okay? Using our simple interest formula, we would do this. Interest equals principal times the rate times the time. It's in there for 3 years and it's compounded every year. What that means, compounding, is that means you get the interest at the end of the year and then you add it to your account and then you earn money on that full amount. So you're earning interest on your interest, and that's how your money grows. So if you have a savings account, that's a great way to do it. And sometimes they compound it more than annually, monthly or daily even. All right, so if we have $3,200 and our rate, remember our rate is in percent form, we have to turn it 2 decimal places to put it, or 2 spots to put it in decimal form. So it would be point, and we'll put a 0 there, 0.048. So our percent would be 0.048. And our time, well, our time is going to be 3 years. However, we're going to do it annually. So we're not going to do it one time and we have it in there for 3 years. We're going to do it after 1 year, and then add that, and after 2 years, then add that, and after 3 years. So I'm not going to do my time here. My time is actually, because I'm doing it annual, will just be 1. So I'm going to do this and get my interest after 1 year, okay? After 1 year, I go 3,200 times my interest rate, 0.048, which will be 153.6. I earn $153.60 after leaving that money in my account for a year. Now that's my money, so I get to add it back to this money, and the next year, so I'm going to put year 2 here. The next year I have 3,200 plus 153, so I'm going to add those together, and I'm going to get 3353.6. That's how much money I have, $3,353.60 in my account. You can add the 0 for a placeholder. Now I take that times my interest rate of 0.048, and I do it for another year. Okay, so I'm going to multiply this out, and I'm going to get 160.97. So the interest rate, or the interest I make after the second year, is a little more than the first year because I added that, and now I get to make $160.97 the second year. Now that's my money. I earned that in interest. I add it back to the amount I already had, as long as I don't take anything out. By year 3, that's what I want to know after 3 years. So I'm going to add this back. When I add this back, I end up with, let's see, let's go 160 plus 3353.6. And I'm going to get, hold up. Okay, I'm going to get $3,514.57. Okay, so that's after the second year. That's how much I have, and I just do it one more time to get year 3 after the third year. Okay, so I'm going to go, my interest is going to be this times, I got to add this, and now I have this amount. I'm going to multiply it by 0.48, and that's going to land me at 168.69. So that's the interest I make after the third year. And then that I get to add back to the amount I have, and that's how much interest I'll have after 3 years. So 3.5, so add these two together, and that should be your answer. Plus the 168.69 I had, and my answer after 3 years should be $3,683.26. And that's how much I would make after 3 years compounding. So it looks like this. They rounded it up 1 penny, but this is what I would have. All right, a bicycle originally priced at $225 was marked down 30%. After a week, it was marked down another 15. What's the final sale price? So be careful. If you take 30% of this, you get an amount, and then you're going to take 15% of that amount. Don't add these together and take 45% right off the top, because that would be 45% of this amount, not of the amount that was marked down. You have to do these separately. So if I want to find 30% of 225, it's marked down. So I can go 225 times 30% and then subtract that from 225. Or since I'm subtracting off 30%, what I'm really paying is 70%. So I'm going to do it the easy way and just go, all right, this is 225 times 0.70. Change 70% to a decimal. And that's how much I have. And then I don't have to do that subtraction of the 30% at the end. 225 times 0.7 is 157.5 or 157.50. So that's after the 30% markdown. 157.50. Okay. Now I'm going to mark it down another 15%. So I can multiply this by 0.15 and then subtract it off of this. Or I can just go, if I'm marking it down 15%, I'm actually paying 100% minus 15% would be 85%. I'm actually paying 85% of this. So I'm going to multiply this, turn it to a decimal, move over 2 spots, 0.85. Okay. So 157.5 times 0.85 is going to give me 133.875. I'm going to round that up to 0.88. And that would be my actual final sale price. Now, if I had done this and I had marked it down 30 plus 15 right off the bat, it wouldn't give me the correct amount because I have to take 15% of this. Careful. Okay, number 20, a store originally pays $25 for a wallet. So that's how much they purchased the wallet from the distributor or whoever they got the wallet from. Then they mark it up 60% to sell it for a profit. So they mark it up so they can sell it in their stores and make a profit. What's the selling price of the wallet? So we want a percent increase. It's a markup, right? So if it originally cost $25, now if we're marking down, we can multiply by 30% or actually take the 70%. This is a markup. So I want my whole amount plus 60% more. So I can do 25 times, turn it to a decimal, figure out what the 60% is, times 0.60. 25 times 0.60 is going to be 15. That's how much I'm marking it up. I'm marking it up $15, so I got to add that back to the 25. 25 plus 15 is $40. That's my selling price. Or another way I could have done this is for markups, I can go $25. Since I'm selling it for 60% more, I take my original amount and I'm going to add on 60% of my original amount. So if I want my original amount, I would just go 25 times 1. That's my original amount. And then I'm going to go 25 times 60%. So I could just multiply by 25 by times 1.60, okay, or 160%, okay. Move it over 2 decimal places, 1.60. So this would cover 100% and the extra 60%. So instead of going 25 times 60, finding my amount and adding it back to 25, I just go 25 times 1.6 or 160%. And that's going to give me $40. So this is the quicker way to do it. This takes a little longer, 2 steps. This is 1 step. So when you mark up, multiply it by 100 more than whatever this is, because you'll have your 100% plus the 60%. That's the markup. When you mark down, you take your percent and subtract it from 100. So when you mark down, if you mark down 30%, instead of doing the 2 steps where you find 30% and you subtract it, just do 1 step by saying, well, mark down of 30% means I pay 70%. And just multiply that by 70%. That's the 1 step. Okay, both work. So show the equation used to get your solution. Here's one equation. I could have done this. Here's another equation. And I could have done this. Both are correct. All right, guys, that's how you do Practice Benchmark Chapter 6. Please email me or come to my live tutoring session on Thursday at 10:30 if you need help.